to the BreakbulkONE show, where we bring experts together to discuss issues and innovations that are impacting Project Cargo and Breakbulk. Today's show is presented by Hyster, a major lift truck manufacturer. So I'd like to start with some introductions. Herman, let's start with you.
Hi, my name is Herman Klaus. I'm responsible for capturing customer needs and working with our engineering team, delivering solutions for our big trucks that take advantage of our technology and our capabilities in high intensity operations. That includes electrification options and products that are used at the ports and terminals.
Okay, great. Barry, let's move on to you.
Hi, Leslie. So I'm the big truck industry manager for Hyster Company. I primarily cover the Western United States, and I'm responsible for almost all of the major port and terminal operations along the Pacific coast.
Okay, great. Jan Willem, we'll move on to you now.
Hi, my name is Jan Willem van der Brand. I'm based in the Netherlands. I'm the Director of Global Market Development for the big trucks. This includes all the container handling equipment as well, and the terminal tractors, and really globally rolling out our zero emission strategy at that.
All right, great. Now, our fourth guest today is not from Hyster. He is from Nuvera. Lucien, tell us about yourself and a little bit about the company.
Thank you, Leslie. Yes, my name is Lucien Robroek. I'm the CEO of Nuvera Fuel Cells. Like in the name, we're working on fuel cell engines and all kind of equipment to use hydrogen for propulsion. My background is in port equipment as well, but also in heavy duty applications. I'm happy to talk about those in this session. Thank you.
What factors are currently pushing ports and terminals to change their operations to include electric equipment from traditional ICE powered equipment? And what are customers saying about decarbonization? Barry.
So Leslie, from my standpoint, the factors there are essentially three factors. There's the environmental, the financial, and the social. So on the West Coast primarily, but I think it's also across the country, or at least moving in that direction, government agencies like the EPA nationally and like the California Air Resources Board at the state level, they regulate criteria pollution emissions. Those are NOx and HC and particulate matter. But since the passage of the Clean Air Act in 1970, both on-road and off-road vehicle emissions have become increasingly stringent. One exception has been CO2, also known as greenhouse gas. So this has largely been not necessarily in the background, but it's really becoming much more so in the foreground. New standards that are under consideration by CARB, which are expected to be implemented in 2028 and 29, will require anywhere from a 5 to an 8.6% reduction in CO2 at the tailpipe. On the financial end of it, major investment firms and banks like BlackRock and UBS, which is a Austrian investment banking house, they've cast themselves as champions of transition to clean energy. And BlackRock, in particular, has set a net zero emissions standard for all of the companies in its portfolio, effective or hopefully by 2050. And then this also extends to companies like some major marine shipping giants, which in one case, they've set a near-term net zero commitment to reduce global temperatures by 1.5 degrees Celsius. And this is not by 2050. This is much closer in. In other cases, their contracts with logistics companies require that those companies support and have commitments to net zero operations. Finally, there's the social dimension. And I think we're all aware of wildfires and climate warming in places that it didn't previously warm. And that obviously affects people that live in the United States and elsewhere. And so those individuals collectively are, pushing the government towards renewable energy resources, as well as pushing the companies from which they buy products in that direction as well.
All right. Jan Willem, I want to talk to you now and get your perspective on these questions. Are you seeing a difference in Europe and maybe other places around the world?
Well, there's a lot of similarities. Like Barry's saying, there's government pushing for example, in Europe, we have the European Union with the Green Deal really pushing towards the climate and that piece, and we have national governments all working in either conjunction or like in the UK, separate from that, but towards these climate neutral goals. So what we have seen is, for example, what is maybe different in Europe is that with the current energy crisis going on and the grid challenges, the whole energy transition piece is also playing a major role. And we see governments pushing for a different energy setup, which also will impact ports and terminals as potentially large users of zero emissions energy, be it hydrogen or electricity. And the grid challenges make ports and terminals already think about what they have to do to meet these goals, like Barry was saying, in the future. And that has really increased in the last year, and we see a lot of interest there from ports and terminals, seeing how are we going to tap into that future, and now with all these challenges. And then there's a lot of funding. I think we'll talk about that later on different levels, be it regional, be it national, or be it corporate by some companies that have a very green agenda and willing to put money in to get started on that journey.
Electrification has been a topic of conversation that's grown in interest over the last few years. While it's all still new technology, what are some things to expect from electric equipment? Herman.
Hi, Leslie. Electrification of material handling equipment isn't really new technology. Hyster company's been producing smaller electric forklifts and warehouse trucks for almost 50 years. What is new is the size and the power requirements of the electrified equipment and the lithium-ion battery technology that's making this transition possible. Lithium-ion batteries really is the game changer. It enables the performance and the runtime needed for these applications. And so now we have manufacturers in the process of introducing these new electrified trucks into the market. So yes, what can you expect? Well, there are really several different benefits resulting from electric equipment. One is, basically local emissions are eliminated. In most breakbulk and container applications, diesel-powered equipment's used for moving or loading and unloading of goods. But with the electric trucks, the emissions and the smell of diesel exhaust are gone from the trucks that are electrified. On top of that, operators are going to notice a smoother and quieter driving experience. And this ergonomic improvement ultimately will increase their satisfaction and even their productivity. Another thing is electric trucks generally require less maintenance than diesel trucks do. Without a diesel engine and a transmission, planned maintenance is reduced, which ultimately lowers operational costs. And finally, electricity costs are generally much lower than diesel costs. So again, the energy costs should also be much lower. Now, having said that, there are some downsides to the electrified product as well. Today, refueling a diesel truck, it's simple, straightforward, and it's quick to accomplish. In a few minutes, an empty tank is fully restored and the equipment's ready to get back to work. But when you have a battery electric truck, refueling is a bit more complicated. Vehicle has to return to a charger. Charging can take 1, 2, 4 hours or more just to get 8 hours of operational time. Although the truck can get benefits from opportunity charging, and that's where you plug a truck in and gain some additional runtime while it's charging during break times. Also, you're kind of dependent on an operator who has to remember to plug the charger into the battery during breaks or at the end of the shift, or else there's no refueling of the battery. And then on top of the other logistic challenges for chargers, there's some added challenges for bigger fleets. If many trucks are needed to be charged at high rates at the same time, in that situation, many users won't have the appropriate energy service levels from the grid to support big fleets of trucks. So the dynamics of and logistics of charging and charging the battery, in some cases, are going to be a minor hassle for some applications, and they're going to be unworkable for others. Many users just won't be able to work around the downtime for charging. Which really brings us to another type of electric truck, and that's one that uses a hydrogen fuel cell to generate the electric power. Hydrogen fuel cell powered truck is still an electric truck. It still has a big lithium-ion battery, although smaller than a pure battery electric vehicle. But it'll also have a fuel cell and hydrogen fuel tanks. And the hydrogen fuel cell will use the onboard hydrogen and produce electricity with it. And that electrical energy then is used to charge the battery as well as to partially charge the truck or power the truck. So the truck operates just like a battery-only truck, and it uses most of the same components. But the real benefit comes when you have to refuel the vehicle. Instead of having to sit on a charger for hours at a time, a hydrogen truck can be refueled about as quickly as a diesel truck can. And since the hydrogen fuel cell is continuously charging the battery, there's really no downtime for charging required. And it just eliminates some of the other challenges of charging and of the grid. But like battery electric, there's some drawbacks to hydrogen fuel cell as well. Hydrogen fuel cell vehicles likely cost more than a battery electric truck will, and they may have nominally more maintenance required, but it should still be less than diesel. The other item to consider at the moment, energy costs will probably be much higher with hydrogen, but most projections show the hydrogen costs will change and drop dramatically as production comes on stream. And unfortunately, at the moment, hydrogen might not be available in all locations.
All right, Jan Willem, why are ports an ideal application for HFC powered equipment?
Well, the ports are interesting, especially because it's a very concentrated area for energy use. You have a lot of trucks using a lot of diesel today at one area. Like, when you have over the road trucks, you need to have energy sources around the long haul route. In the port, it's all very concentrated. So that is good for hydrogen because then the infrastructure setup is a lot easier in that respect, and the supply of distributed hydrogen much more focused. Second is that the machines in the port, as Herman was already saying, are large machine with an own weight of 80, 100 ton, and they need to be very productive. We all know that the ports have congestion and they need to work 24/7, and especially during peak hours cannot afford any downtime for charging and that kind of thing. So it's a very intense, high productivity area that really drives that need. The other piece of the port is square meters is the key thing. That provides you ground slots to put your containers or your load there. And so square meters are at a premium. And if you have a lot of trucks needing to be charged, they are standing somewhere, right? And the charging infrastructure also takes square meters. So the infrastructure required to do the hydrogen refilling, and because it's so quick, has a benefit there as well. And the other big thing is that the planning of the equipment today, with the mobile plant, is using the TOS system to plan the loads and plan the work. But if you, on top of that, have to plan, which truck goes to which charger at what time, that adds a lot of complexity, and especially during peak hours and erratic demand for the trucks, this brings a lot of challenges that with hydrogen you do not have. And so that really brings a lot of clear cases why hydrogen in the ports would be, one of the early adopters. And I think a lot of people have seen that, and that's also, for example, if you've seen, the Hamburg approach to hydrogen, that's where they see the early adoption of large-scale hydrogen use, for example, in Germany, turning the hydrogen economy on.
Interesting. All right, let's turn to Lucian, who is the expert in hydrogen fuel cells. Tell us more about that technology, um, and how they work, and a little bit about what infrastructure is required at a port to support that option.
Okay, thank you, Leslie. Yes, try to keep it simple. Herman already explained that you can have a fuel cell engine on board as a charger for your battery, using the hydrogen from your tanks that you can more easily refill than charging a battery. But what happens in a fuel cell engine, which actually is a kind of electrochemical plant by itself. It's using hundreds of cells. In each of these cells, the process that we know as hydrogen and oxygen converted into water and electricity is taking place. So it's feeding hydrogen, using oxygen out of the air, bringing it together and controlling that process. And while that is happening, it will produce electrons, which is actually electrical current, and water as a byproduct. So what you get out of the exhaust of a fuel cell engine, because it still has an exhaust, is extremely clean. It's water, or actually vapor, and some of the air, meaning that the emission is completely gone. There's no smell, there's no toxic gases whatsoever. Now, you can scale up these engines depending on the power you need by adding more cells and building bigger stacks. But the crucial point there is to really balance the size of the fuel cell engine and the remaining battery that you still will have on board. So typically, say roughly, if you take the same duty cycle and you can take out, and you compare it to a battery-only vehicle, electric vehicle, can take out 2/3 of the battery and replace it by a fuel cell engine. You need the engine, you need the extra tanks, and you need some heat rejection like a radiator that we're used to already. And that aspect is actually the same for any vehicle you have there. So if you look at ports, ports are very interesting, and Willem already explained some of it. Because ports really need that duty cycle. Many of the ports have a 24/7 operation with limited time to charge, or you need to buy extra equipment if you want to park some of your vehicles, and you don't want to do that. So fueling the tanks of a fuel cell engine-driven electric vehicle, again, takes as much time as you're used to with a diesel engine. So the whole logistics is much easier. Now, the other point is that you already touched on the infrastructure that we need for hydrogen, actually a full hydrogen society, because we're really talking about big changes there on gas. Gas that is not currently available. Yes, there is some production of hydrogen gas. It's being used in some chemical industries like steel making and fertilizer. But if we really want to go green, we need to get hydrogen gas from sustainable sources like solar or wind, or to some extent from nuclear power. Now, the ports are a very interesting place because there's a lot of industry already in the ports, and not only chemical industry. So in some cases, production of hydrogen is already taking place in some of the major ports, but also transportation from other, say, parts of the world where there is more solar or wind, where they can produce hydrogen. It needs to be shipped to the points of consumption. And that typically happens through a port, whether that's a pipeline or a ship. So that's where the fuel cell industry would benefit from having easier access to hydrogen as a nucleus for the whole industry. Now, the third point I want to make with the ports is that there's a lot of equipment moving around in the port. It's not just port equipment. There are many vessels, seagoing vessels, but also port vessels. There's many on-road traffic with big trailers, big trucks that leave the port. They all need to be electrified, and they all have this same heavy-duty demand that, in our opinion, most often will need a fuel cell engine on board. So they can fuel in that port where the infrastructure is easier available. And yeah, Nuvera is lucky that we work in all those segments. So really deploying the same kind of technology with the same kind of fueling and infrastructure is beneficial to drive this whole kind of emission-free electric heavy-duty equipment forward.
Yeah, absolutely. It's an ecosystem, I think, in itself. How does the cost of ownership compare to an equivalent ICE or compression ignition engine powered truck? Jan Willem, I think this one's for you.
I think what you need to realize is that the cost of ownership of the terminal or the port, you have to see the whole system. We used to compare the cost of ownership basically on a truck by truck level. Your truck against somebody else's truck, or an empty container handler versus a reach stacker. But in this case, you really need to check the whole system. So what is the cost of the infrastructure, the grid connection, the hydrogen supply, the downtime of the truck? So how many trucks do I need with what mode, whether you go electric or hydrogen, right? You have to understand that total view to get a total cost of ownership and operation at the terminal level. So no longer really at the truck level or at the fleet level, but you really have to look at the terminal level. And I think compared to diesel, that's not the right comparison. We need to go to zero emissions, right? And it's going to be more expensive than diesel is today. That's where we are, because you need to make the investments in the infrastructure. The trucks are going to be more expensive, but we all need to go to zero emissions. And there's going to be greenhouse gas taxes, and basically in several areas you will not be able to operate anymore with diesel equipment. So that comparison is for each terminal different. We have terminals, smaller terminals, that would be better off using purely electric. They have electric power supply from renewable grids. They have a modest duty cycle with only a couple of trucks, and electric would work very well for them and would be the best cost of operation and ownership to do. While when you have a very busy port with a lot of trucks and you need to invest a lot of money in the infrastructure, or you would have to have more trucks to get to the same productivity to compensate for the charging time, etc., then hydrogen is the right way to go. So this is a bigger puzzle that's no longer on the truck level, but it's really on the port level. And that's where we've been working with different ports to simulate, what would be best for you, taking all these factors into account. And that's a process. That's not a one-day meeting. You need to understand, where's my electricity coming from? If I make everything electric, what is my grid demand? How many kVAs do I really need? And what you also have to say is that it's not only inside the fence what happens on the port, but it's also outside the fence. The ships need to have shore power. Those are very, very high demands on the grid, right? When you have a container ship, a large container ship, that's megawatts that it's pulling from the grid. On the other side, all the lorries that will be visiting your terminal, right? If they have to make long round trips, they expect to be charging at your port. Those are hundreds of lorries a day. All of that needs power. So you really have to look at that whole infrastructure and see, how will I get all that power on my terminal? How will I cope with the peaks? And what would be the best solution for me? And maybe it's a mix. Some trucks electric because they have a slower and lower duty cycle. and the others that are really doing the work need to be hydrogen. But it all depends on the terminal by terminal basis, where you are located in the world and what the challenges are. And that's going to be the interesting puzzle in the next few years, what we all need to learn, what will be the right optimum for every terminal. And I'm looking forward to a lot of discussion with, with the ports, the terminals, but also the municipalities. What is it that they will do? Many ports say, from a port perspective, like Rotterdam or California, we need to be at this level in 2025, this level in 2030, but they also need to then work to get the infrastructure and the circumstances there that we can make the transition and we can make the right choice, giving also stability on certain regulations and those kind of things going forward. Because these are not small investments, these are long-term, large investment in the infrastructure, and they need security on what's going to happen.
Yeah, absolutely. Let's turn to maintenance and repair. What does that look like for these electrification options, Barry?
Yeah, so on-site service technicians will need to be trained, obviously, and experienced to maintain and repair high voltage electrical components. There has been a need for additional gearmen and to plug and unplug the truck from a battery charger on trucks designed with a battery only. This can be and has been eliminated with the use of wireless chargers, which only require the operator drive onto a pad, and the charger automatically raises into position and charges the battery for whatever period of time the operator can allow it to occur. On the refueling side, on hydrogen fuel cells, it's really comparable, I think, as Herman already mentioned, to diesel trucks. The method and the time required is very similar, and the proficiency can be gained quite quickly.
All right. Our last sort of aspect of this topic is labor, which we all know continues to be in short supply in many places. Ports are under pressure to get the most productivity from a limited workforce. Ergonomics play a key role in that. So, what we want to know is there a learning curve for an operator to transition from a diesel to an electric truck? And if there is, what does that look like? Uh, Barry.
Yeah, so Leslie, essentially there are three factors. There's environmental, financial, and social. So government agencies like the EPA nationally and the California Air Resources Board at the state level, they regulate criteria pollutant emissions that are generated by fuel combustion. Since the passage of Clean Air Act in 1970, both on-road and off-road vehicle emissions have become increasingly stringent. The one exception has been CO2, also known as greenhouse gas. New standards that are currently under consideration by the California Air Resources Board, which are planned to be implemented by 2029, will require 5 to an 8.6% reduction in greenhouse gas emission at the tailpipe. Financially, major investment firms and banks like BlackRock and UPS, respectively, have cast themselves as champions of the transition to clean energy. BlackRock has an ambition to be net zero across its entire asset portfolio by 2050, which effectively means that their investments are going to be in companies that are committed to greenhouse gas reduction.
Interesting. So we do have benefits there as well, both for employees and the general environment at a port. Um, and I lied. We've got one more thing to talk about. What role do incentives play in helping ports electrify, and what entities provide those incentives? Jan Willem, I'm going to ask you those questions.
Yeah, we're at the beginning of a transition, and governments know that, like with electric cars or anything else in that to get the cycle started and get the initial volume build up where, we get some kind of scale, it needs incentives to make the change. And incentives come in several different ways. One would be that you tax the dirty alternatives, so the prices of diesel go up or you need to pay for it. And the others are subsidies to, to make the transition. And the subsidies can be really, there's two main ways. One is just pure subsidy on buying zero emission equipment. So you will get, in many cases, like in Europe, you'll get a certain amount of the add-on price that for example, electric truck would cost more than a diesel. You can get that subsidized by the government. So that's really subsidizing, rolling out these equipment and putting the cost down. The other subsidy is really project subsidies, where, if you have a terminal and you're going to make the transition, there is a government subsidy on getting the infrastructure, even the training, the trucks and everything there in some way or form funded. And the early projects that we are doing, like Port of Valencia or also in California, are all part of some type of subsidy program. And there's more to come. Europe has announced large subsidy scales. Germany, 8 billion and so on and so forth. So not only for port equipment, but also on road and so on, and the energy transition. And I think, that's very good and really plays an important role to get the initial trucks out there, get the learning curve started, and build up of the volume, right? Because we need these bigger components to get to the right volume level, so that the electric motors for this big equipment are being produced in the same volume as diesel engines today, right? Because that's what's going to drive the cost down in the end.
Excellent. All right. Well, I want to thank all of you for the great information that you've provided today, and I feel like you've inspired people to not be afraid of this transition and have done such a great job in outlining the benefits, timeline, etc. I would like to mention that we have Breakbulk Americas coming up at the end of September. That's the 27th through 29th of September in Houston, and Hyster will be exhibiting there. So if you'd like to speak with them in person, we invite you to join that event.